Hello everyone. Today I am going to discuss about unit number 2 in basic mechanical engineering. There are two major topics. One is manufacturing process and another one is thermal engineering. As the subject is clearly directed as is, we are going to look at the basics of these two processes. So this is the syllabus for the basic mechanical engineering. So unit 1, unit 2. So unit 1 already I discussed in class. Unit 2 and unit 3 we are going to see. Unit 3 already you have a video already I uploaded in YouTube. You can refer. Now I am going to talk about the unit number 2. So first we are going to talk about the manufacturing process, principle of casting, forming, joining process, machining, introduction to CNC machining, 3D printing, smart manufacturing. Thermal subject we have boilers, different cycles like Otto cycle, diesel cycle, refrigeration and air conditioning, IC engine, two-stroke and four-stroke engine, SI and CI engine, and the components of electric and hybrid vehicles. So these are all the topic we are going to see. So first I start with casting. So casting, it is a manufacturing process in which the molten metal is poured in a mold cavity and allowed to solidify. Molten metal on solidification get the shape of the mold. The mold has the shape of the product to be made. This work you are doing in your workshop laboratory, what is called foundry or casting. So first we are doing molding process. So molding means making the mold cavity, making the mold cavity. And casting means you are melting the wax and pouring. Finally, we are making the solidified. The solidified piece of the metal or wax, it is called a product or it is called the casting. If it is a metal solidify and forms a desired shape, it is called metal casting. If wax is solidified and made it into a required shape, it is called the wax casting. So this process almost it is like a idli making process, casting. So we are rice, we are crushing and making like a liquid. Then we are pouring into a cavity. Then finally allowing the steam through the liquid form of that rice. Then finally, after steaming, we will get the idli. So initially, it will be like a liquid. Finally, it will be a solid. So similarly, metal we are melting, scrap metal or any metal we are melting and made it into a liquid form. So finally, whatever desired cavity we are making, we are pouring into the mold cavity. We are getting the casting. So this is what the simple principle behind the casting. So let us see the various stages of casting. Casting process we have two things. One is sand casting and another one metal mold casting. We have sand casting means the mold cavity is formed by using sand. Metal mold casting is the mold cavity. It is formed like a permanent mold by using plaster of Paris or some material we will do it. And you have a die casting. It is made up of EN steel or some other steel. The desired cavity it is made. And the die casting, you have a hot chamber die casting and a cold chamber die casting. This is a different types of casting. Apart from that, jewelry industry, they are using investment casting, shell molding, different types of process of there. Now we are studying the basic mechanical engineering. Therefore, we are just look at the basic classification. So here casting, it is a molten metal. We are going to see some terminologies. The casting, it is the molten metal. It is a metal in the form of liquid. So casting means widely we are doing it. Sometimes if it is a plastic, we are pouring into different shapes like that. Here we are talking about metal casting. Therefore, the molten metal is metal in the form of liquid. So mold means this is what I said. It is a cavity making, right? A desired shape. Negative print of the product to cast. Cavity whose the geometry dimensions in the shape of the cast. It is a open or closed mold. So molding means it is a process of making desired shape in the by using pattern or something. So molding means mold cavity making. Then mold you have a consist of cope and drag. So molding box, you are using two boxes, upper box and the lower box. So here upper box it is called as a cope and the lower box it is called as a drag. And the pattern means it is a model of the object to be cast. In your laboratory, you are making some gears, some double shape. These are all called models. Here we are pouring the molten metal like this, right? Melting and after reaching the metal into liquid form. And finally, we are pouring into the mold cavity. This hot molten metal fills the mold cavity. Finally, we are giving time to solidify the molten metal. So after that, after solidification, removing the mold, that sand, whatever it may be, removing them or opening the mold. If you take it out, your final component is ready. So this is called mold box. This is upper of lower of cope track. You can put it CD. C means scope, D means track. Here the pattern, upper half of the pattern, it is lying at cope, lower half it is with the track. So this is the way we have to arrange. So that this material completely it is called mold material. If it is a sand casting, this is a sand. Or if it is a permanent molding, this might be a metal. Then open and closed mold. In our discussion, we have seen open mold and closed mold. Open mold means they are pouring. So the mold box is completely exposed to the atmosphere. Closed mold means it will be like this. We are setting runner and riser, runner and riser. This is your cope box, drag box. Here, this is your mold cavity. Here we are pouring our molten metal. So molten metal, it will be slowly coming down and filling the mold cavity. So later on, it is going to the riser. Once the molten metal, if you are able to see at riser position, that is the identity for the filling of mold cavity, right? So once if you are seeing the metal here, so that is the filling. You have to stop pouring, right? Then if you are allowing some times for solidification, so the cast metal it starts to solidify. Then slowly the metal available in the riser. For example, here metal if it solidify, once it is solidified, it will shrink. Then again, that the shrinkage cavity, it will be compensated by the metal available at the riser part. Okay, so this is the important thing. Therefore, riser not only it is giving identity to filling the mold cavity, and it is giving like the cavity. If any cavity comes, shrinkage cavity comes, the molten metal at the riser, it will come down and fill the shrinkage cavity. Therefore, you will get the complete molding. Now we are look at the part of gating system. You have a boring basin, sprue, runner, gates, riser. So here I will show it in the picture. So here you have a riser. Here you have a pouring cup. This is called a runner, right? Runner, riser, pouring cup. Then again gates. So gates means here we are unable to show, but at side view you will get it. So you will get the, we will form the gate. So this is the original gating system. If you look at that, this is your pouring basin through which you are pouring the molten metal. This is called a sprue, through which it will be almost like a funnel shape. Then finally here you have a sprue basin. Then after sprue basin, the metal it is flowing like this. Here you have a runner and gate. You have a runner through which the molten metal enter into the mold cavity. You people will ask, sir, why not one runner is sufficient? One gate is sufficient. If you are giving only one gate, before filling the mold cavity, metal will get solidified. Therefore, if you are giving two, therefore metal it will flay 50% of the cavity occupied from this gate, and remaining 50% it will occupy 50% of the mold. Therefore, your mold cavity it will fill. So once cavity is filled, metal it will be raised here. So later on, because of shrinkage, metal it is in liquid to solid form. That conformation, that what is called compression, you will get some cavity formation, right? What is called concentration means shrinking. That shrinkage cavity that will be compensated the metal available from riser. So once this process shrinkaging compensation of shrinkage cavity, so overall the casting the your cavity is completely filled. Once it is over, you can cut the riser and gates, runner, etc. All the pieces. You will get your required casting. Steps in sand casting. First, you have to make a core, prepare the sand, then you have a pattern making and pattern you are bringing here, sand is bringing here, then core it is connected with pattern. So once if it is ready, by using sand we are doing molding process. So your mold cavity is ready here. Once mold cavity is ready, we are melting the metal and pouring into the mold cavity. Now we are allowing for solidification and cooling. So initially metal it is at a very high temperature. Therefore we need to wait some time for cooling. Then removal of sand mold. So once solidification cooling is over, then you have to remove the removal of sand mold, breaking the sand mold, and we will take it out the solidified piece of the metal. Once it is completed, then you have to clean. Cleaning means cutting the runner, riser, so all the gates, everything cutting out. Then you do cleaning process. Then we will put it for inspection. Any surface defect or any internal defect, anything is there, or blowholes are there, it's one of the defect. You will identify through the inspection. Then after once it is passed from the inspection, you can able to get the finished casting. Look at the various steps. I think the steps you are doing in your laboratory. If you're not completed this experiment, I think this time you might be completed. You look at first. You put one half of the pattern here on the molding board. Then put your drag box, fill the sand and press. Then again invert your mold cavity. You have fixed another half of the cavity. Put a runner, riser, then fill the sand and ram it. So now the complete casting is ready. So after doing this, you separate the molding box and remove the cavity. Ideally, it will be like this. Now your mold is ready. The vent they are giving through hot gas streams that will escape through this vent hole. Otherwise, that steam, gas, everything storing within the mold and it will cause some defects. So now mold cavity is ready with vent. Now if you are pouring the molten metal through this, now what happened? Molten metal, it will fill the cavity. Once cavity is filled, it is a metal flowing into the riser. Once if you are seeing metal at riser position, you can stop pouring. So once metal solidification, the shrinkage cavity during solidification that will be compensated by the metal available in the riser position. Now during cooling, you are keeping vent, so your hot gas, steam, everything it will escape through this. Otherwise, if you are not putting vent, the hot gas, steam, everything it will store into the mold box or that casting itself. So that will be with a lot of defects. Then molding sand, you need to have some basic property like flowability, behave like a fluid and get compacted uniform density. That is one of the good property. And green strength. Green strength means you should not talk about the color. Green means moist state. Strength of the sand in moist state. Then dry strength, the strength of the sand at dry condition. Porosity, permeability means ability to allow the uh, passage of mold gases. So this is important, permeability. Otherwise, the hard gases, everything, it will be stored into the casting that create a lot of defects. Then refractoriness. Here, this property is important. While pouring the molten metal, your sand material or mold material, it need to withstand very high temperature. Otherwise, if the sand it is started to burn means, then you will not get the required casting. That shape it will be different. Uh, the burned portion of the sand again it will enter into the molten metal that create another kind of defects. So sand trapment that defect is called. Then adhesiveness, ability of the mold sand to stick on the mold wall. Then chemical stability. Chemical resistance means chemical stability means hot molten metal should not react with the material. If it is reacting and creating byproduct, again that byproduct it will be a defect. It will end with defect. Then collapsibility, fineness, sand produce smooth surface casting. Then coefficient of expansion. Sand, it is a very less coefficient of thermal expansion. It will not expand. Otherwise, what happen after pouring the molten metal, the cavity it will expand, the size will increase. So again, you have to do machining and reduce the dimension. That involves cost. Then again, durability, ability of the stand to used for long time. And advantage of the metal casting is production process is simple, cost of casting is low, sand can be reused. Disadvantage is more chances of defect. This is a big problem, right? If sand quality is not good or not having the required properties like porosity, permeability, this kind of things are not there. It is very difficult to control the defects. And it does not import good surface finish. You know, the sand, it is the one of the rough material. So that surface finish, it will be more ups and downs will come. So therefore, that required some finishing, some machining process. It is used to finish the component into the desired shapes. So next I am coming to different casting defects are possible. One is called hard tear and blowholes, porosity. Porosity means that a corner, that particular portion, you will get a cavity. Then again, shrinkage cavity. If riser is not functioning properly, that would be the result. Then you have a scob. Then you have a swell. Some swelling means like enlargement in size. Then misrun, cold set. So cold set means before filling the mold cavity, the metal it will get solidified. So once metal solidified at different position does not allow inside, right? That is another defect. You have a different casting defects like blowholes, cold set, misrun, and hot tear mismatch, sinkage cavities. And if you are not properly designing the riser, this will be possible. Then swell, scab, these are all the basic defect. So I do already I explained the defects. I don't want to read the text. So probably you will freeze the video and you can read the text. This is other than sand casting. This is called die casting. This is card chamber die casting. Here your molten metal is there. If you are putting this is like a injection, like hot die casting, right? Here just if you are pressing the plunger, it will metal available here. It will flow and enter into the mold cavity. By using water, flow of water, they are putting over the mold and cooled the component. It will be taken out. So for the components of motor, it is made by using the die casting process. Next, I am coming to metal casting is over. Now I am coming to metal forming process. Metal forming process. Metal forming means initially you have a metal. By applying load, we are changing the shape. So initially metal it will be in certain form. It is in the form of rod, uh, bloom, billet, block, different name it is called based on the dimension. Now that metal, if you want to change the shape, if you want to change the shape, this is without this process we can't do. So metal forming by deformation. So process in which the shape metals are changed, desired shape, subject them to stress greater than yield stress of the material. You know, yield strength means it is a stress level. If you apply beyond this load, then metals start to deform. So initially, whatever raw material, whatever workpiece you are using, first we need to know the yield strength. You try to apply the pressure beyond that, apply the load beyond that, then only metal formation is facilitated. Here you have a applying load, it will be in three form. One is rolling, forging, and extrusion. These three are important process. Just I start with the rolling process. Rolling process, it is a process of plastically deforming metal by passing between the rolls. This one you take it example like sugar cane juice extraction. You know, two rolls are there. In between the two rotating rolls, they are inserting the sugar cane and extracting the that sugar cane juice. You know, in between they are putting some ginger and lemon. Finally, we will drink. You know, so keep rolling process. You keep this example in your mind, so it is easily understandable. So you have a hot rolling and cold rolling. Hot rolling means metal is heated some temperature and putting into the roll. What is called hot rolling. So why hot rolling is required? Metal, if you are applying heat, then what happens? Strength, it will metal, the ductility, it will reach. So therefore, lesser load, you can able to deform the metal. Otherwise, what happened? You need more load. Some material like aluminum or soft material, you need not heat. The cold rolling is sufficient. So already I said sugar cane crushing, right? You have a upper roll, lower roll. In between that, you are inserting the plate, right? Before inserting, it will be with this much thickness. After inserting, the thickness is reduced. So here volume remain constant. Whenever thickness increases, length it will be extended. So overall volume it will be constant. This is called rolling process. If you are inserting hard workpiece in between the rolls, right? Hard rolls in between the hard metal into this roll. Then it is called hard rolling. If you are inserting cold roll, it is called cold rolling. So the process principle is like this. Okay, if you want to reduce the thickness, reduce the diameter, or if you want to make any specific shape, these are all possible by using rolling. So hard rolling, as I said earlier, heating above the recrystallization temperature, then doing rolling. Cold rolling means metal is feeded when below the recrystallization temperature, sometimes room temperature also. Some soft metal like aluminum, tin, zinc, tin, this kind of soft material, you need not heat. Again, if you heat, then what happened? The oxidizing is other problem. Again, that oxide scale formation you have to remove through some other process. Therefore, some soft metal cold rolling is always preferred. Next, coming to types of rolling mills, you have 2 high, 3 high, 4 high, cluster mill, tandem mill. This is completely based on the number of rolls available. 2 high roll means only 2 rolls are there. Like I said, the past diagram. 3 high roll means number of rolls will be 3, 4 number of rolls will be 4. Cluster means many. Tandem means that also with multiple rolls. So two rolls, lower roll will be fixed, upper roll is variable because you are feeding different thickness of the material. Therefore, upper roll they are keeping movable, and suddenly the thickness is more. The upper roll little bit raised and inserted. The job is inserted between these two. Both rolls it will rotate in same speed but opposite direction. When you look at this, both roll, if it rotate in opposite direction, then only it will what happened? It will pushes the material through this. If rotating in both direction, it is not allowed. And this is a two high roll, roll one, roll two, bottom roll, top roll. Already I said the top roll is adjustable. So look at before that the thickness is somewhat more. After rolling, thickness is reduced. Then three high rolls means here you look at the roll structure, right? Three high rolls. Here you have three highs. Both rolls are there. First, we have to insert this roll and again putting into another roll. Two, three high rolls. Initially, job is feeded through this. Sometimes it will be with somewhat some rolling. Directly, we cannot do it with a single rolling. First time, initially, we will do one rolling. Then after the rolled component again insert it, so therefore you will get it. If you are suddenly giving more load and if you are doing that, then metal it will get damaged. Surface it will be rough, or the what happened? The tearing, this kind of defect you will get it. Then cluster means many. So look at three rolls are there. These rolls, the rolls which is contacting with workpiece is called work roll. Workpiece connected with that roll is called work roll. And similarly here you will have a backup roll. Backup roll in the sense it will not allow the roll to bend. If material is more hardness or material thickness is huge, sometimes roll will get bent. For that they will put a backup roll. So look at the rolling direction. So this work roll, if you look at that, both will rotate in opposite direction. Then only the job will be feeded through the rolling mills. Next process is forging process. So a forging process means metal. We are applying load. We will take a hammer and continuously applying load through repeated blowing. Finally, made it into the shape. This is you have hot forging and cold forging. Hot forging means first metal is heated, then we are doing forging operation, applying load. Cold forging it is the doing at room temperature. Generally, material like aluminum they will do cold forging, whereas hot forging, particularly the agricultural instruments, if you want to make anything, they will use hot forging. First, metal is heated. Once it is reach the retained red heat condition, red hot condition, then they are applying load. So then what happened? Even they will take a small hammer and bend. Same steel or steel material, if it is at cold condition, you need to have a big hammer and more effort is required. So to reducing the effort, we are doing hard forging. Anyway, hard working, cold working, that is a different thing. Even less load you can able to deform, but oxide scale and other defects are associated with this. Then here the components produced by the forging process. What are the component you can do? This is application of forging process. Nail, it is used in the forging process. Bolt, spanner, crane hook, axle, crankshaft, connecting rod, automobile connecting rod. These are all the made up of forging process. Then dies used for forging. There are open die and closed die forging. Open workpiece is upset or compressed forged between the two claws. Upsetting means increasing diameter. Then used for simple shapes and low production volume, it is widely used. Look at the die. This is the upper die. This is a lower die. Billet means it is a workpiece. Initially, it will be like a square shape. After application of load, it will be like a oval type. Then further, if you apply the load, the thickness will reduce, length will increase. So this is the basic mechanism of metal forming. In case of closed die for forging, you will be the die is completely forged. You are putting the material inside. You are applying load in both direction. So therefore, the metal it will flow through the empty direction. Finally, you will get your material like this. So another diagram it is available here. You can able to see this is like upper punch, lower punch. You have upper punch and die. Once the material, the both dies are closed and apply the load at top, you will get your said shape. Types of forging you have two category: hand forging, drop forging, and press forging. If component is very small, hand forging is sufficient. Drop forging means the weight is suddenly dropped over the material and changing the shape. And press forging means by using pneumatic press or hydraulic press, we are changing the shape. So hand forging, it is hand tools for hammer, chisel, uh, this kind of things they will use. But it is not suitable for mass production. So this is called hand forging, heating metal and putting the hammer. Initially, it will be a square shape. Finally, they are putting and this become flat. You know. And similarly, the hand forging operation, you have a different operation. Start with upsetting, drawing, setting down, building, welding, cutting, swaging, different operations are there. So this is called the upsetting process. So initially rod it will be there, continuous application of load, they are changing. This is called increasing the diameter. Then next I am coming to the drawing operation. This is somewhat like wire die, the wiring operation, right? Drawing operation, wire drawing or some other. Initially the workpiece it will be somewhat thicker one. Through the die, if you are applying some pulling load, then what happened? The size of the wire it will be reduced. For all the aluminum wires, copper wires used for power supply connection, they are using the drawing, bending, welding, swaging, drifting, fullering. This is called bending operation. You look at some of the component, it is used in bending operation. Even this cold bending, you can see the concrete rods are bending, what is called cold bending. You can made it into your desired shape. This is called forge welding. Two workpieces are heated and placing one over the another and repeatedly blowing, you will get a forged welding. And this is called drifting. This is called fullering. You have a upper die, lower die. Workpiece is kept in between the die and applying force. Drop forging, it is like load is suddenly applying over the material. This is the typical what is called a hammer, right? Workpiece is kept. If they suddenly, if you are leaving, automatically it will come due to gravity. The heavy weight is acted over the workpiece. So after application of load, the component it will be like this. Next one, press forging. Drop forging, uh, instead of drop forging, they are using hydraulic press or pneumatic press, what is called ram and die. So in between these two, they are putting the material. So upper die and lower die. So it is placed now here they are applying the high pressure fluid. Sometimes it is the pneumatic means high pressure air will come, hydraulic means high pressure oil will come. So both will pressed between two dies. The material it will get a required shape. So this is a typical hydraulic press. Then extrusion process, this is like a toothpaste system. You have a three category: direct extrusion, indirect extrusion, cold extrusion, or impact extrusion. Direction means the material flow, it will be in the direction of applying load. Indirect extrusion means where you whenever you are applying load, the metal flow it will be in opposite direction. Cold extrusion or impact extrusion means load is suddenly acting on the material and allowed to float. Direct extrusion, so this as I said earlier, it will be the metal through die in same direction movement of the ramp. For example, this is a direct extrusion. This is like a piston cylinder arrangement, right? Here they are putting the workpiece. Here you have a ramp. Another end you have a hole, what is called a die. If you are applying load through this direction, then what happened? Initially, workpiece size it will be like this. After extrusion, the diameter of the rod it will be in the wire form or different shapes. This is called direct extrusion. So as the name indicates, the force applied in this direction, metal flow it will be in the same direction. Application of force and the direction of the metal flow both will be in same direction. Therefore, it is called as a direct extrusion. Another one, indirect extrusion. So here you look at load is here they are using hollow ram. Whenever you are applying force in this direction, the metal it will flow in the opposite direction. So this is called indirect extrusion. Uh, you have a cold or impact extrusion. So initially the workpiece they are keeping like this, and workpiece is suddenly dropped or gradually they are applying load. Therefore, initially the metal it will be like this. After application of load, the gap between the die and punch metal it will flow and form the cup-shaped component. Next, I will go for welding. Welding it is a process of joining two different material. In your classrooms, you are seeing different thing. Your benches that square pipes are welded together, and finally they are making the desk for you. If you see the windows, all the it is a mild steel material where it is welded together. Finally, they are making the window structure. Welding is a process of making permanent joint, establishing into atomic bond two or more pieces by using heat or heat and pressure. Sometimes we will use a heat, arc welding, simply we will use the heat. Sometimes spot welding or other processes. We are applying heat and pressure. So here welding most essential requirement is heat, pressure, sometimes applied, some process not required. They are using filler material for some welding process, something is not required. Some welding process flux is required, some process is not required. So therefore welding is a process of joining two similar or dissimilar metal by application of heat. Right, this is the basic definition for welding. Let us go to the classification of welding. Welding, pressure welding, fusion welding. Pressure welding like forge welding, just now we discussed in the metal forming, and pressure thermit welding, and you have a resistance welding, you have a spot seam, but fusion welding means you need not apply any pressure, that even the heat input it will be get joined. You need not apply any load or anything. So here you can use metal or carbon or atomic hydrogen, inert gas. Inert gas you have big and thick. You will see later. And gas welding here, oxyacetylene, other fuel gases. Then finally fusion thermit welding. These are all the basic classification of welding process. So the advantages of welding, it will give a permanent joint in many applications. The overall cost of the welding equipment is low. Large number of metal can be welded. Even if you want to weld ferrous, non-ferrous material, it is possible. Welding operation can be mechanized. Welding operation is economical. High corrosion resistance compared to bolting and riveting. Disadvantages of operation distort the workpiece. This is a big problem during welding process because heat input suddenly applying to the material. Therefore, this distortion everything. By experienced weld operator, he will control. Then skilled labor is required. Skilled welding welder is required. Then welder joint required some heat treatment if you want to relieve the that distortion or residual stress during heating process, and it gives the harmful radiation during the welding process. These are all the considered as a disadvantage. This harmful radiation, this will affect your eye. Probably your workshop after completion of welding, you will get eye pain. Only reason is the radiation which is emitted during the burning of metal. Then application, so you have a big list, almost all the application, aircraft, automobile, bridges, building, pressure vessel, storage tank, piping, ships, machine tool, household, heavy machinery. So almost many places the welding it is taking the application. Next, coming to gas welding. So here welding is heat is mandatory. Previous welding process, we are bringing the heat from the electricity. Electrical energy is converted into heat energy. In gas welding process, oxygen, acetylene burning together, it gives some heat input. That heat input is used to weld the material. You have oxyacetylene, here acetylene, oxyhydrogen. So here oxygen is required, basic thing it is required for heating, generating heat. Acetylene is a fuel. Sometimes instead of oxygen, you can use the atmospheric air for welding process. Sometimes oxygen, instead of acetylene, you can use the hydrogen as a fuel. So this is the typical oxyacetylene welding interface. Here C2H2 methane plus oxygen mixture it is coming here. So more heat input is produced here. Therefore workpiece is melting, filler material is melting, molten metal from the workpiece, the molten metal from the filler, both are mixing together and weld bead formation. That joint is formed. So this is the welding torch you have. This is the filler material, right? You have to weld stage by stage. After completion of welding, slowly if you move, the complete plate it is getting welded. So here, this is the usual thing you can avail. You can see in many workshops. Here you have a red is acetylene cylinder, black is oxygen cylinder. They are drawing both gases. Here you have a mixer, and this is called a torch. Just light here, you will get a flame. This flame which gives huge heat input. That heat input, we are melting the metal and welding is taking place. So oxide welding equipment, the welding rod is filler metal that is required. Without that, we can't weld. Flux is required. Sometimes borax flux is used. Then welding torch, it is a basic element. You have a different types of welding, high pressure, low pressure. So types of flame, you have a neutral, reduction, oxidation. Neutral flame means it gives more heat, and that means 50% of oxygen, 50% of acetylene. Reduction means oxygen is more, sorry, the fuel is more, that is acetylene is more, oxygen is less. Oxidize means oxygen is more, fuel is less. So for based on our application, we are choosing the different types of flames. So look at this: neutral flame, oxidizing flame, carburizing flame. Then advantage, you have a lot of advantage, right? Here easily controlled. So here no electricity is required. Directly, if you are taking acetylene and oxygen, that the cylinder, that is self-sufficient, and easily you can move the gas welding cylinder one place to another place. It's a portable welding process. Disadvantages means like your commercial cylinder available we are using now. That gas welding process we can't weld much of the material. And again, sometimes if cylinder get blast, it become a big accident. These are all the things it is considered as a disadvantage. Then arc welding and electrodes, we are using arc welding, electric arc welding. We are generating arc, then that arc which gives the huge temperature, 6,000 to 7,000 degrees centigrade, and that heat input we are utilizing to melt the material. Here we are using consumable electrode and non-consumable electrode. Sometimes copper, carbon, graphite, tungsten, high temperature, high melting point material. It is used for non-consumable electrode. Sometimes they are using electrode, consumable electrode also, like steel electrode may be bare, uncoated flux, different types of electrode. Here, what happen? Electrode it will melt and form into liquid. Workpiece also melt and it become liquid. The molten metal from filler means electrode and workpiece material mixed together. and form the weld bead. So these are all the different types of arc welding. Among this, the metal arc welding, it is widely used in many applications. Even if you take some places near Chittor, if you look at that, we have a lot of industries. Each and every industry, they will use the welding process, that arc welding process. So it will be like this. You have an electrode workpiece, the weld joint, it will be like this. So this thing, I think I don't want to explain much of the things. Already in laboratory, you are doing the same, you know. So this is a manual metal arc welding. This is a transformer. Here your one end is connected with the electrode holder. Another end is connected with the uh, workpiece. In between arc is generated. More heat input is generated. That heat input it is helped to melt the filler metal and parent metal, and finally we will get the required joint. So this is a shielded metal arc welding. So shielded metal arc welding means here you have a electrode is there. There they are coating like cement color coating. They are giving what is called iron oxide coating. You have many advantages. So that iron oxide coating generally what happen it will melt, and after molten metal is melting, that electrode material it will cover the welded joint. So therefore, the welded joint is completely prevented from the atmospheric contact. Therefore, weld bead it will not get any defect. So for that purpose, they are doing coating. Apart from that, you have a resistance welding. You have here they are instead of heat input, they are using electrical resistance. So this particular welding process it is used in automobile manufacturing. That means automobile body manufacturing. So this process it is used for welding the sheet metal. Right, two sheets are arranged like this, one over the another, like lap. Then in between that, it is placed between the two electrodes. Now we are supplying the power. So electrical resistance, it will be inside here. So now what happened? We are applying pressure. Therefore, the heat input is generated by the electrical resistance. Then weld bead is formation. Look at here. The weld bead formation, it will be inside the metal. It will not, you cannot see at the top surface of the sheets. Similarly, you have a MIG welding and TIG welding. So MIG welding and TIG welding means metal inert gas welding, tungsten inert gas welding. Tungsten inert gas welding, they will use the tungsten electrode, right? Through which the heat input is supplied, filler metal separately added. So therefore, because of heat from tungsten electrode, workpiece will melt, filler metal will melt. Then finally, both are combining together. You will get the weld bead formation, joint formation. Here, MIG welding means the filler wire it is directly supplied. So this is non-consumable electrode. Here they are using consumable electrode. Here metal it is consumed like this, right? It will act as an electrode as well as a filler material. So this MIG welding electrode it will be like a wire, right? Smaller wire. That wire it will be fed through this. Therefore, that wire and the workpiece in between interface heat input is generated. That heat input, the workpiece and filler metal melt, and the required joint is uh, facilitated. Comparison of MIG TIG already I discussed. Here they are using tungsten electrode. Here they are using consumable electric consumable wires. Both process they are using cooling. That means argon cooling, something they are doing. So this is the basic difference. So anyone, if you want to see the difference in detail, you can freeze this particular page and you can read. Again, the like casting process, welding process also you have a lot of effect like weld crack, weld porosity. You have undercut, spotter, slack inclusion, poor fusion like this. Weld crack means if suddenly the weld metal, if it is make contact with the atmospheric air, the atmospheric hydrogen it will trap inside. You will get the crack formation. Porosity means if they are not properly providing shielding gas, porosity will form. And a spotter, if more temperature, so a metal melting point, low temperature is required. Suppose if you are giving more current, more temperature, you will get the spotter. And the slag inclusion means sometimes the electrode coating is there. No, if you are that coating that electrode, it is used for a long time. That slag it will melt and it will be trapped into the weld metal. Then finally it become a slag. and a pure fusion if coating is not properly worked. Metal, it will get a poor fusion, or sometimes called incomplete fusion. Then wrapping distortion. So this is a major problem. So welding allied process also you have. Here they are using soldering iron. Soldering iron, I think you can see at electronics laboratory. This will be, they will use some tin wires, low temperature wire. Normally the melting point of this material is 200 around. Uh, Simply they will take electrical line from the panel board. They are generating heat. So with lower temperature, it will melt and join. This is called joining, circuit joining. In our electronics laboratory, they are using for joining the circuits. You have different types of soldering, soft soldering, hard soldering. So only difference is the temperature. 152 and 300 degrees centigrade is the melting point. If melting point goes more than 300 degrees centigrade, it is called a hard solder. You have a lot of application, joining wires in electronic connection, electronic boards. Then coming to bracing application, somewhat bracing also, it's like a soldering process. But here we are heating, they are applying for more than 450 degree centigrade. Generally, the bracing, they are using gas welding setup for bracing work. You have a torch, furnace, resistance, different are there. The torch welding, you can use the gas welding setup. The application of the bracing, fastening the pipes if you want to join two pipes, or a stove burner, carbide tip tools, radiator, heat exchanger. This kind of the metal is like a tubular form. They are using the bracing process. So this is the typical application. You look at this gas welding torch is there. You have a cylinder, you have a plate. If you want to weld the cylinder over the plate, you can use this process. This will be like a gas welding process. You have to use the filler wire. Next, I am coming to machining process. You have a traditional machining and non-traditional machining. Machining, generally it is called cutting. It's a circular shape or other shapes. If your work is in circular shapes, you can use turning, boring, drilling. If it is in other shapes, you can use milling, planing, shaping, shawing, like different process. Apart from that, you have a non-traditional machining. So non-traditional machining, the machining rate, it will be very slow, and you will get a very good surface finish, very good dimensional accuracy you can maintain. Now what you can do is after the conventional machining, traditional machining, for finishing the component, normally they are using the non-traditional machining. Next one is lathe. So lathe, you have a different component. I think this lathe you can see in our workshop. Here we are holding our job and clamping. Here it is called a gearbox. Here it is called a tool post. This is called a tailstock. Suppose your job is very long, you can give a support to tailstock. Then yeah, from here job will rotate. From here you have to feed the tool against the rotating job. You will get the metal machining. Right. So this is the simple shape. So here this particular portion it is enlarged here. Here it is a headstock. Lathe is there. In the headstock, workpiece is clamped. Tailstock they are giving support, and here they are keeping the tool and doing the machining. So here job will be rotating, tool it will move in this direction. Therefore metal machining it will be carried out. If you are using lathe, you can do a lot of operation like facing means reducing the length. Then turning means reducing the diameter. You have a contour turning, form turning, different types of turning. And here it is called grooving. Here you have a threading, and you have a boring, drilling, knurling. This kind of process you can able to perform. Even that tailstock end, you fix the drill bit and you can do drilling, you can do boring. And here here you remove the tool and you add the knurling tool. You can able to make the knurling. So this knurling tool it is used to provide the grip. So drilling means this is the conventional drilling machine. Here you have a motor. Uh, Drill, it will be in rotary movement. Here you have to keep your workpiece and drill. Right? Here rotary movement and linear movement both are giving. So drill already it is rotary movement, If you are activating this handle, the drill, it will be feeded, a rotary drill, it will be feeded against the fifth job. Therefore, you will get a hole like this. You look at this picture, tool is rotating, and again we are pressing the tool towards the workpiece. Therefore, you will get a drilling. Look at the drilling tool. You have some cavities, gaps. Through this gap, the chips it will come out. By using drilling process, you can do a lot of operations like drilling, boring. Drilling, boring difference is drilling means it is a process of making hole. Boring means enlarging the already drilled hole. Reaming, it is a finishing process, finishing the already drilled hole. Here, tapping means it's like putting the internal thread, what is called tapping. Apart from that, you have other process also there like spot facing, counter sinking, counter boring like this. And this is the typical machining, drilling machine. Sorry, this is a milling machine. So milling machine also somewhat like drilling process. Workpiece is fixed. Tool will be rotated, and they are feeding the tool against the rotating workpiece. Here, what we are doing is drilling. It will be rotate. It will be in rotary movement. Feed we are giving towards the workpiece. So finally, you look at the milling, what is called a face milling and end milling. So face milling here, you look at the height of the job, it is reduced, right? Suppose if you are feeding like this, rotary movement and feeding they are giving. Therefore, you will get a machining. And similarly here, if you want to here look at the thickness is reduced. Here, if you look at that, width is reduced. So this is the difference between face and end milling. Then this is called a different milling process used. Conventional milling, here you have a partial face milling. You have a end milling. This is almost like a drilling process. This is called a profile milling, profile making. And next I am coming to CNC machine. CNC machine means already we have seen the lathe and everything. So instead of human, if you are controlling through computer numerical control, it is called a CNC machine. So almost lathe machine, instead of manual operation, the drilling, milling, different operations already we are programming and we are doing the machining process. So this is almost like a automatic process. Just the job loading and unloading is a manual work. Remaining all set of operation through programming, we are running computer program, we are doing the operations. And a different operation, whatever operation we are doing with lathe, same thing we are doing. Here it is a manual work, here it is a program. Next, I am coming to next topic, what is called 3D printing. 3D printing, already you know, it is like latest technology. It is there, manufacturing process. It is called additive manufacturing. Additive manufacturing means, for example, you take a machining process, your component is there. Slowly, we are removing the material and making the desired shape. Whereas 3D printing, we are adding the material layer by layer and making the required component. So here we look at structuring this three-dimensional object in physical configuration form into digital forms. First layer, second layer, third layer. Similarly, we are forming layer by layer. Finally, we are getting the required component. What is called a 3D printing and additive manufacturing. For this, you have a there is a 3D printer available in our institute. I will show it, demonstrate it later. Initially, what we are doing means we are taking 3D CAD file, 3D CAD file by using SolidWorks or some other software. We are modeling the component, and we are using that slicing software. Therefore, it will be sliced into different layers. Now that input it is given to 3D printer, so therefore your 3D printer it will print layer by layer. So finally, you will get your required component. So here 3D printing, this is the picture, it is available. Similar 3D printer you can see in our mechanical lab. Initially 3D model converting into stereolithographic file, then slicing, then G code. G code it will be given based on the slicing. G codes are generated. As per the G code, the 3D printer print the job layer by layer. Finally, you will get the 3D object. You look at the basic 3D printer. Here you have a filament. Filament means like a wire. That wire it is getting melted and it is deposited over the component layer by layer. Finally, you will get your required component. This is you called a positioner. You have a feeder. Feeder means feeding the material, feeding the wire. You have a hot end. This is a printer bed. The printer bed, it will move right to left, front, back. The application of 3D printing, aviation, clothing, dental, automotive, construction, jewelry, and food industries. The cake, it is made by 3D printing. 3D printed cakes, you have 3D printed chocolate. These are all the food. But 3D printing widely used in industry for prototype making. Prototype means initially they will make a sample product by using this. And apart from that, 3D printing, it is extended by using some bioplastic. They will print the organ, bone tissue, drug. They are doing skin tissue. They are developing a lot of medical devices. Right? And next, I'm coming to the Industry 4.0, what is called the digital factories, what is called smart manufacturing. Smart manufacturing, initially it is with simply mechanization, then electrification, that means robot came. Then automation is 3.2, and industry today you have a 4.0. So this is the current technology, what is called complete digitalization, what is called digital manufacturing or smart manufacturing. This industry 1.0 came at 1784, then industry 1870, and the 1969 industry 3.0, that is automation and the computer integrated manufacturing, it is started. Finally, we are using industry 4.0 like IoT, cyber physical system network, and we are doing the manufacturing. So this is the layout for the digital manufacturing. So when you have a time, just freeze the screen. You can just read out what is there. And I will go to what is meant by smart manufacturing. So here smart manufacturing refers to new technology. We are integrating using almost all latest technology to do the manufacturing process. It infuses innovation like big data, IIoT. IIoT, IIoT means Internet of Things. Then cloud computing, automation, then AR, VR technology. Now AR, VR put together. Now it is called as extended reality, using robot by using all the latest technology and doing production, what is called smart manufacturing. Here you can see like integrating the technology. So what are the advantages of smart manufacturing? You will get the improved process efficiency, better quality control, long-term cost reduction, more informed decision making. The quality you can control very easily. Production you can control. These are all the advantages of using smart manufacturing. Next, I am coming to the thermal engineering. Thermal engineering, first topic, you have a boiler. So boiler means, this kind of boiler, you will see the real-time application to understand the boiler. This boiler, you will see somewhere where it is used in tea shops, copper boiler. Here, what they will do means, this side, they will put a fuels, putting firewood or coal, something they are putting inside, and this side they will pour the water. Now, if you fire, then inside what happened, heat will be generated. This boiler, it is used to generate the hot water. If you are allowing hot water for a long time, then it become a steam, high pressure steam, that is used for power generation or some other application. The working principle of boiler is, it is very simple, easy to understand. The boiler essentially a closed vessel inside the water. Water is stored, fuel is burnt, a furnace, hot gases are produced. Now hot gases which comes in contact with the water vessels, therefore heat plus water combined together, you will get a steam. Then application of boilers, you will get a power generation, you will get the heating, tea shops, they are using heating purpose. Other industrial purpose, they are using the steam generation like sugar mill, cement and agricultural. Wherever hot water, steam is required, they will use this. Next, I am coming to Otto cycle. This is an important topic in thermodynamics. Otto cycle, diesel cycle. So Otto cycle means it's like a four-stroke cycle in technical terms. Cycle is used in internal combustion engine. The internal combustion engine, it is called IC engine. This engine, it was built by German engineer Otto at 1861. Therefore, his name is kept. It is called Otto cycle. The Otto cycle, you have four strokes. Intake stroke, that time it will the fuel is coming inside, then compression, Then combustion means it's a burning. Then power stroke, hot gas is generated and which pushes up. Then finally exhaust after power. Then hot gas, everything it is escaped through this. Here it is a first stage 1 to 2 adiabatic compression will take place. Then 2 to 3 heat is added, what is called combustion process. Then 3 to 4 power stroke adiabatic expansion. Here it will the hot gases which pushes the piston power is generated. Finally 4 to 1 it is the out. The hot gases everything it is escaped. The application for auto cycle, it is internal combustion engine, generally four-stroke engine. It is commonly used in most of car trucks today. And conclusion, the auto cycle engines are most commonly used to compare to two-stroke rotary engine. Next, I am coming to diesel cycle. It is ideal cycle for CI engine. CI engine means combustion ignition engine. All the combustion ignition power cycle useful for many forms of automotive transmission, railroad engines, and ship power plant. This kind of heavy duty applications, they are using diesel cycle. Here it will replace the power plug and the carburetor in the SA engine. You will get it. This is the basic difference. Then ideal diesel cycle also it will work like auto cycle. It is also with four stroke. Initially 1 to 2, and that blue color 1 to 2 it is isentropic compression will take place, then constant pressure compression. So this is a pressure, this is a volume. At a constant pressure we are adding the heat input. Then isentropic expansion, this is like a working stroke. Combustion, hot gas is generated, kinetic energy of the hot gas is increased. Then the kinetic energy which pushes what is called working stroke. Then the last stroke, the constant volume, the at constant volume, heat is rejected out. So this is the ideal working of diesel cycle. Here again, you look at intake, right? The first stroke, what happened? It is the fuel. It is coming inside. The combustion now burning start. Compression means the pressure is applied. Now the combustion burning process is taking place. Then exhaust stroke, again, once the mechanical work is over, it will be almost like a return stroke. The hot gases, the gas, smoke, everything, it is exceeding out. So this is almost available in all the heavy vehicles. Difference between auto cycle, ideally it is called SA engine, CA engine. Both differences I provided. Here they are using mixture of air fuel during the suction stroke. Here only air is allowed. Here low compression ratio, here high compression ratio because vehicle is heavy. Charge is ignited by spark plug, here ignited by the high temperature of compressed air. The explosion takes place at constant volume. Here it will take a constant pressure. Quantity method of governing is used. Quality method of governing is used. Generally, this is a lightweight engine. This is a heavyweight. Uh, Generally, auto cycle, and the spark ignition engine generate low thermal efficiency, whereas diesel and the combustion ignition engine it will give the high thermal efficiency. So this is the typical two-stroke petrol engine. Two-stroke means you have only two-stroke compression stroke and power stroke. Compression stroke, fuel suction and ignition, it will be doing at the compression stroke. Power stroke, fuel mixture to cylinder and burned fuel pushed out. So everything it is happening. Generally, this is you have a two-stroke burning fuel pushed out by the combustor stroke. This is at second stage. First stage petrol air mixture. It is drawn inside. Here you have a spark plug. This is a petrol engine. Spark is required. Two-wheeler you have spark plug. No, same thing. Two-wheeler. Fuel is coming here. Spark plug. It will create the spark. Then burning combustion stroke. Then working stroke. Finally, it will be coming out. Burned fuel. It is coming out. There are two strokes. One is upstroke. During upstroke, fuel it is coming inside. Downstroke, burning, combustion, working, yeah, rejection, ejection, everything it is happening here. This is like a four-stroke engine, right? That also somewhat similar, but when compared to SA engine, this is somewhat big in size. Here you have a four strokes: intake, compression. We discussed in diesel cycle, no, same thing. Intake, compression, power, and exhaust. All the four strokes. Then coming to two-stroke cycle, four-stroke, you have a merit of one power stroke, one revolution of crank. But here one power stroke and two revolution of the crank. This is a merit and demerit. Then power developed for the same engine speed theoretically twice of four-stroke engine, but power developed for same engine theoretically half of the two-stroke engine. Just comparing. Then simple design and lighter in construction. This is for same power, complicated design is heavier in construction. Merit uniform torque is obtained. Here non-uniform torque is obtained. And merit starting is easy. Here starting is not easy. These engines are generally air cooled. These engines are water cooled. This is somewhat like a two-wheeler. This is like a four-wheeler or a truck bus like that. So this is the typical comparison between SI engine and CI engine. Almost look like same. SI engine you have two stroke. CI engine you have a four stroke. Here SI engine generally it will be run with gasoline or petrol. Here they are using fuel. Here they are using spark ignition. Here they are using combustion ignition. Here pre-mixed air and fuel is petrol is mixed, pre-mixed. But here directly the diesel is injected into this. So here higher RPM, lower RPM, but higher RPM, lower torque. But here lower RPM, higher torque. Higher CO2, NOx, lower CO2 and higher NX. And this is less expensive. This is more expensive. This is light duty. This is heavy duty. This required less maintenance. This required more maintenance. Then now I am coming to the final topic of the electrical vehicle, the hybrid vehicle. Electrical vehicle, the battery electrical vehicle, you have a number of main components: electric motor, large battery, AC/DC converter, and the electronic circuit. Here there is no oil or fuel tank because this is the electrical vehicle. There is no like petrol, diesel, or two-stroke engine, four-stroke engine, nothing required. Here there is no exhaust system like IC engine, CI engine. IC engine, both engine combustion process is going on, then smoke is coming out. There is pollution and many problems are there. Whereas this one, there is no pollution at all. Straight away, we are using electricity from battery, drawn from battery, and that is used to run the vehicle. The hybrid electrical vehicle, it is a small combustion engine, small fuel tank, electronics. Hybrid means partially diesel engine, partially electrical engine. The fuel cell electrical vehicle has an additional tank and a fuel cell. The electrical vehicles, you have a several wheels and a plug. For example, if you want to working of EV, you have a battery. From battery, DC controller is there. From that, you have a DC motor. The controller takes power from the battery and delivers it to the motor. The accelerator pedal hooks a pair of potentiometer, and this potentiometer provide signal that tells the controller how much power is supposed to deliver. So controller can deliver zero power and full power at any power between these two levels. Next, the major component of the electrical vehicle is electrical motor. That is a base thing. You have a power inverter, power converter, DC, then battery charger. So frequently we have to charge the battery. Finally, you have to give a charge port. These are all the basic component for the e-vehicle, electric vehicle. Then HEV means hybrid vehicle. So already we seen the difference between these two. This type of hybrid vehicle and electrical vehicle that combines a conventional IC engine and electrical system. So you have a even IC engine also you have to suppose if you have a gasoline engine and they will put a petrol system also, SI engine also. Initially the vehicle is started by using petrol. Then again what happened that the combustion and working it will be done by the gasoline engine. And, no gasoline engine directly given. So at initiation, it starts with petrol, then finally the gasoline engine is continued. Hybrid electrical vehicle, it is type of vehicle that combines two or more power sources, usually internal combustion engine and electrical motor. Uh, Generally, it's internal combustion engine. It is to start the initiation, then finally it will be continued through the electrical power. HVE, hybrid electrical vehicle, is a complex system of electronics control and switch between the different power sources depending upon the driving condition to optimize the fuel efficiency and emission. Then construction of The hybrid EV, it starts with the fuel tank, engine, and generator. Generator means power generator. And another end, you have a battery pack. Then you have a converter. For example, if you are running with battery vehicle, meanwhile, if battery got failed, you can run the vehicle by using the IC engine. So here, red color, it is a mechanical connection. Green color is a electronic connection, electrical connection. Therefore, both are associated in this process. So with this, I conclude the unit number 2. So I hope I covered all the topics. Uh, so I hope this video it will be very useful to you. Thank you.